Okay, so let's solve this integral by really looking at what is inside the tan. So you have the tan of x squared plus 2x plus 1 all over x squared minus 1. So let's break that one down. So we can start off by looking at this. Can do this in a different color. So x squared plus 2x plus 1 all over x squared minus 1. This can be written as x plus 1 all squared, right? Because if you FOIL that, that is going to give you x squared plus 2x plus 1 divided by, this is difference of two squares, that is x minus 1 times x plus 1. So this one is x plus 1, the numerator times x plus 1, right? Divided by x minus 1 times x plus 1. So that is equal to what? This cancels that, and I left with x plus 1 over x minus 1. So that is I is going to be the integral of tan of x plus 1 over x minus 1 divided by x minus 1 squared dx. Now I'm going to do a u-sub. I'm going to let u to be equal to x plus 1 over x minus 1. Then I will differentiate this. So du dx. So this is v du, the denominator, keep that one constant, and you differentiate the numerator. Differentiating x plus 1 is just 1, minus, keep the numerator constant and differentiate the denominator. Differentiating x minus 1 is just 1 divided by the denominator squared, x minus 1 squared. So du dx is what? So this one is x minus 1 minus x plus 1. So what we are going to be left with is x minus 1 minus x minus 1 all over x minus 1 squared. So that implies that du is equals to, this cancels that, and I'll leave it negative 2 all over x minus 1 squared dx, like this. So with this one, look at what we now have. If we are now going back to our integral I is going to be the integral of tan. Instead of x plus 1 over x minus 1, I'm just going to replace that with u, tan of u, and then I am going to write this one as negative 2 all over x minus 1 squared, just by multiplying the integral by negative 2, and I'm going to nullify that by dividing by negative 2 all the way in front. And I'll have I to be equal to negative 1/2 the integral of tan of u times this guy, negative 2 all over x minus 1 squared dx. That is here, that is equal to du. So that is our integral. This is now easy. So negative 1/2 the integral of tan of u du. And integrating that, the integral of tan is the natural log of secant of u plus the constant of integration. But what is u? U is what? X plus 1 over x minus 1. So I is going to be equal to negative 1/2 the ln of the secant of u, which is x plus 1 over x minus 1. Okay, so that is what we have. So this one, you can try to simplify it further. You can bring the negative 1 all the way in front using the laws of logarithm. So that's going to be 1/2 the ln of the secant of x plus 1 all over x minus 1. This one raised to the power negative 1. That is using the laws of logarithm. And you're going to have 1/2 the ln of 1 all over secant of x plus 1 all over x minus 1. I'm sorry, it should be a square bracket. So I is going to be 1/2 the ln. 1 over secant is cosine, right? Because 1 over cosine is secant, 1 over secant is cosine. So that is the ln of the cosine of x plus 1 all over x minus 1. Plus the constant of integration. Forgot that all along. Okay, so this is the value of our integral. Therefore, if we integrate this guy here, This one is going to evaluate to the 1/2 the ln of the cosine of x plus 1 all over x minus 1 plus the constant of integration. So this is how you evaluate this integral. Yeah, so if you find this helpful, make sure to give me a thumbs up, subscribe to my channel, comment down below and let me know how you can solve this integral. Anyway, that's it. If you find this helpful, make sure to give me a thumbs up and subscribe to my channel for more content. I thank you so much and I'll see you in the next one. Bye bye.